future exploring the transformative power of 5G and beyond. From 4th December to 9th December, organized by Electronics Engineering Department, Rajki Engineering College, Sonbhat. It gives me immense pleasure to introduce and welcome our eminent speaker, who is from industry. One is Murthy and another is Nitesh Pradhan from Vividian Technologies Private Limited. Kindly give a round of applause for them. Now I would like to welcome both of you. I would like to request Dr. Vijay Pratap Singh sir and Mr. Deepak sir kindly welcome with a plant. Thank you, sir. Mr. Pradhan received BTech in NIT from NIT Raipur. He is a passionate engineer, author, and senior sales professional. Actually, those who attend the yesterday lecture, he knows very well how much the capacity of explanation he has, and he is very much potential to do anything in any software or hardware. He is a much more expertise. You can see there he is expertise in USRP, LabVIEW, test stand, system link, versatile, flags logger, everything he loves to do. And this Murthy is just 1.5 years ago completed his graduation.
2 years ago.
Two years ago, and now he is in Vividian Technologies. So you also can learn from him how fast he is about to grow in industry. So I would like to invite both of you, kindly start your session.
Thank you.
में आपको सीखना है, आपको समझना है, आप उसे देखिए। एंड उसके बाद मैं हार्डवेयर डेमोन्स्ट्रेट करूँगा। तो यहाँ पर ये दोनों चीज़ें आपका हो जाएगा कि अगर हम एक थ्योरी या कोई भी चीज़ें स्टडी कर रहे हैं, ठीक है, तो उससे रिलेटेड हार्डवेयर कैसा होगा, क्या काम करेगा, वो भी हम एक्सप्लेन कर देंगे। अगर आपको क्वेश्चन, हाँ, पहला क्वेश्चन ये है कि why we are going with the Murthy's lecture based on the USRP, तो मेरा आंसर होगा कि जब आप इस USRP पे काम करने चालू करेंगे, तो मैं डेमोन्स्ट्रेशन अभी स्टार्ट करता हूँ नेक्स्ट 2 मिनट, तो आपका हमेशा रहेगा इससे ऊपर का USRP भी तो कुछ हो सकता है, अगर हम ये करें तो इससे बड़ा भी कुछ हो सकता है। सो Murthy will break down everything टीचिंग एंड रिसर्च और बीटेक ओरिएंटेड प्लेटफॉर्म में, जहाँ पर आपके पास 4 साल होते हैं, एटलीस्ट 6 महीने ही होते हैं, 6 महीने के 20-25 दिन ही होता है एक सब्जेक्ट को आपके पास, तो जो आप दे के चलते हो, वरना हम तो एक रात वाले थे, ठीक है। तो
ये भी एक रात वाले ही है।
हाँ, ये आप में से कोई ऐसा है जो 5 लड़के एक रूम में रहे हों और एग्जाम से पहले एक क्वेश्चन बैंक परचेज किया और 500 बड़ा किया और पढ़ाओ? तो इंजीनियर हो फिर। आपको जिंदगी में कोई भी रुला नहीं सकता सिवाय तुम्हारी सोची हुई गर्लफ्रेंड के, और आपको कोई डिमोटिवेट नहीं कर सकता है। ओके, सो Murthy will start, देन हंसी मजाक हम Murthy के सेशन की बात करेंगे, आपको बहुत मजा आएगा। आप लोगों के लाइफ में जब के माइंडसेट मोटिवेशन है, मैं उसको पहले चेंज करूंगा, फिर हम प्रोग्रामिंग स्टार्ट करेंगे। सो Murthy, go ahead.
Yeah, thanks. So, good morning everyone. I'm Murthy. I work as an applications engineer in Vividian Technologies, and I welcome all of you to this session of presentation. So, in this session, like we will learn like what is USRP and what are the software defined radio offering that we have from the National Instruments. So, we'll get started.
Go to back. Yes.
So, So we'll get started on this NISDA platform. So we'll start the session like with having a brief introduction about like VVDN technologies and like what we offer like when it comes to the software defined radio platform, and how we can use this SDR platform for any kind of academic research when it comes to 5G or the cellular communication applications and those things. Like we'll look on the brief overview part during this session. And we'll also learn like how we can use this USRP SDR with the help of an open source software like GNA Radio or LabVIEW, which is a proprietary software for doing any kind of signal processing application and all. So if I talk about VVDN technologies, so VVDN technologies is it's one of the fast growing manufacturing company which is located in India. So this company is focused on the main latest technological trends in the industry. So whether it comes to the 5G, networking or Internet of Things, cloud computing and computer vision. So all of this latest has been main focus for the VVDN technologies for having bringing innovation in the technology. So this company drives the passion in work like with the motto of having create, innovate and produce. So this is the main motto of VVDN technologies, like in developing any kind of application and giving a solution to the society when it comes to the in solving the problems in the engineering domain and in the society. So VVDN Technologies is headquartered in Gurugram, Haryana, and it is located in different parts of the country. So in different cities in major cities like Chennai, Bangalore. So and not only in India, VVDN Technologies is also like established in other parts of the country as well. So VVDN has established research and development labs, some manufacturing facilities, so sales offices and innovation centers. So with all of these facilities established like in VVDN Technologies, like there are almost around 10,000 plus of employees in the company, so who are working as a team. So how we work with National Instruments is that we all know that National Instruments is one of the biggest player when it comes to the test and measurement equipment manufacturing. So National Instruments provides the test and measurement hardware, and it is also producer of the virtual instrumentation software such as LabVIEW, and the other sorts of software applications. So and NI has gained the trust of VVDN Technologies has gained the trust of National Instruments, and in VVDN Technologies we have a business unit called as VVDN Tools. So where we are the authorized channel partner for National Instruments. So what are the hardware, whether it be a PXI system, whether it be a compact DAC or a CDAC, or whether it be a USRP, or whether it can be a software application that is developed by National Instruments. So all of this hardware we have got VVDN has the authority to distribute across the India and provide the technical support on the NI portfolio. So in this situation, we have a website link like VVDN Tools /National Instruments. So if anyone want to get to know about National Instrument products, like what are the latest products and latest offerings that we have from the National Instruments, so we can get to know all of this in the VVDN in this link VVDN Tools /nationalinstruments.com. So this is how we work. We have become the authorized channel partner for NI. So now we will learn software defined radio. So when it comes to software defined radio, NI is the biggest player in software defined radio, and we will learn what is software defined radio and why do we need software defined radio. So we have software defined radio, which is the latest technology. So when we say software defined radio, we can tell software as some set of instructions which is executed by a programming processor. And when we say software defined, we can tell that we are referring to the use of software processing in order to implement any kind of operating function. So the operating function can be varying of amplitude or changing frequency. Any sort of operating function can be done with the help of a software. So this we can tell it as a software defined. But when it comes to the radio, when we compare the traditional radio system and the modern radio system, what we have. Okay. we can refer to the use of software processing to implement any kind of operating function. The operating function can be like where we will vary the amplitude of a signal or change the center frequency or tune to a different frequency, like any sort of like operating functions that can be implemented with the help of software, so that we can refer to it as software defined. But when we call radio, so like when we have, like when we compare the radio like what we have in the modern days and the traditional days, so like in the modern days, like majority of the like baseband processing, the RF processing and the intermediate frequency processing is all done on the physical layer, which is the layer of an OSI model. So in such a case, like since all the processing is done on the physical layer, we can tell software defined radio as a device where we will perform like some of our or all of the physical layer functions in on software with the help of a software. So and this is how software defined radio is called. And we can tell software defined radio as a complex device, like which will perform any n number of tasks simultaneously, such that like we can easily transmit signal and receive signal. So and the modern communication system are so advanced nowadays that like we majority of the baseband processing, like processing of a signal can be done with the help of a software by using the flexibility of the hardware what we have. So the hardware is so flexible that like with a one hardware only we can tune to different frequencies. So this flexibility along with the software has given to the birth of software defined radios. So and this is how like we will use the software defined radios, and this is called software defined radio. And if we see why do we need software defined radio, is that traditionally we have analog systems. So like as the communication system become more modernized, like we got the transition from analog to digital. So the changing network standard, so like availability of the spectrum and robustness, so lot many other considerations when it comes to the communication. So the digital systems are made into a necessity. So for this necessity, software defined radios have like is very much needed for having the SDR platform. So interoperability. So when we say interoperability, so when we consider a military application, so we will be having a radios, will be having a different set of radios, like which are operating on different frequencies and that are not compatible with one another. Suppose like we have a radio that operates on the 2.4 gigahertz and we have a radio that operates on 5.4 gigahertz. So in such a case, like two radios cannot communicate with each other directly because the frequencies are tuned different. In such a case, we can use the single USRP with multi-channel, such that like USRP or a software defined radio acts as a translator between two incompatible radios. So this is how yes. In this way, software defined radio acts as a translator between two incompatible radios or multiple incompatible radios. So that eliminates that provides like a good advantage of having the communication system. So then when we say efficient use of resources, so like if we
go to the directly
yeah. So then efficient use of resources, if we say efficient use of resources, like suppose like if we want to monitor signal and if we want to download any huge amount of data, in such a case like we can use like a software defined radio at a very high bandwidth with more power in order to quickly download any kind of information. Otherwise, like if we are operating on a battery powered system, so in such a case like we can like tune the hardware to operate on the low power signal also. So in such a case like we can use the resources efficiently, which gives very much like advantages like flexibility for using the hardware. So then when we say opportunities frequency reuse, so like suppose like in the spectrum is not limited because like most of the spectrum is licensed. So in such a case like we can use software defined radio hardware for monitoring the spectrum. So in any situation like when the spectrum, one of the spectrum is not using the spectrum and the spectrum is left unused, in such a case like we can use SDR for continuously monitoring. When the spectrum is being unused, like we can go and quickly use the spectrum for certain duration, for the duration what it is unused. So for this kind of application also we can like software defined radio is needed. Then future proofing. So suppose like a new communication standard has been rolled out, so we can use the radio system like previously if we consider SDR, so which was which we are using like 4 to 5 years older. So at the we can use the old SDR and deploy the new like communication standard. Suppose like we want to do a research on 6G or beyond 6G. So we can use the same SDR deploy all the do all the software processing and use the same SDR for future proofing, for prototyping the next generation applications as well. So then research and development. So SDR find application in R&D. So like in academic research and in the like industrial research. So SDR is a good hardware platform which will reduce the duration for gives flexibility of doing the research in a quick way. So this is these are the majority of the needs that made software defined radio into a necessity. And all of this necessity has made software defined radio to deploy any kind of application with less duration. So since the hardware is so flexible that we can reconfigure the hardware a number of times, and we have the software flexibility, like we can use the graphical programming method for quickly prototyping any kind of application on the software stack. So then we can use we can also write codes and we can quickly prototype the device as a end-to-end system. So any kind of application can be done in a quick session with the help of software defined radios, and this is the major advantage of having the SDR platform in terms of when it comes to the research oriented application. So some of the application where software defined radio find is majorly used is that we will use software defined radios for deploying a communication systems. So for rolling out any 4G or 5G or 3G cellular standards, we can use SDR as a base station for setting up we can use SDR as a user equipment for measuring the communication system to have an end-to-end system. Then we can use SDR to simulate radar. So we can use SDR system for satellite communications. So then we can use SDR for spectrum monitoring, radar prototyping, SDR for direction of finding. So where we can find the signal transmission with the help of direction find application, and signal intelligence. So so these are the major application areas where software defined radios are majorly used. So when we in software defined radios we have different software defined radios, there are different vendors other than NI, we have Adam Pluto from Analog Devices and all. So out then HackRF, ATAL SDR, which is only the receiver software defined radio. So out of all of these software defined radios we have the National Instruments software defined radios, which is the most popularly used software defined radios and most powerful SDR platform. So the software defined radio offerings that we have from the National Instruments are whether depending on the various application requirement, whether we want to have a standalone software defined radios, or whether we want to have a field deployable software defined radios, whether we want to have a very high powerful baseband processing hardware for doing the SDR application, or a board mounted basic student application oriented hardware. So we have, depending on the requirements, we have the different offerings from the NI. So where we have the host based software defined radios, which we can quickly use it to connect to the computer with the help of USB connection, or otherwise we it's a portable device where we can, it is so small as a credit card size, we can carry this software defined radio hardware in the pocket, and we can do spectrum sensing in the fields. So we can have a software defined radio hardware called field deployable SDRs, so which are the rugged SDRs. So where we can deploy SDR on the extreme temperatures or the cold weathers and rainy areas and dusty areas. So in such a scenario also we can deploy SDRs. So then if we want to have a SDR on a standalone basis, so we have a SDR called as USRP X410 and USRP 2974. So where we can use this SDR as a standalone capability, where this SDR comes with Xilinx ARM Cortex processor as well as the Intel Core processor along with the FPGA. So we can run the operating system within the hardware along inside the SDR itself. So and this acts as a standalone device. So if we want to have a multi-band processing, so baseband processing, so then we can go for a high baseband massive processing SDRs. So and if we want to operate on the millimeter wave technologies, so at the very high frequencies, So then we have the millimeter wave vector signal transceivers, where we can use the VSD with this like VSD and millimeter wave VSD, and we can also use the USRP with the millimeter wave up and down converters in order to convert the in order to make the 6 GHz USRP to operate at the 44 or 24 6 GHz frequency range. So in such a case we can use this hardware. So then when we want to have the processing on do an FPGA processing, in such a case where we do all the baseband processing on the USRP itself, we have a high FPGA based USRP with which is the USRP X310 and the FlexDio. So where we get the Xilinx Kintex FPGA, which is the larger FPGA, and which is open for programming. So in this hardware the FPGA is also open for programming. So and the basic USRPs are the B200 or B210 that we can use as a student SDR for getting started with the software defined radio exploring.
Which I just suggested yesterday about that lab setup and other, that will come with the B200 series, that B2, that is the ETAS and ETAS USRP, and जो USRP 2901 है ना, उसके अंदर B200 ही होता है, like this is USRP 2901, and इसके पास जो हुआ है USRP B200, तो B210 जो है ना उससे ही ये बना हुआ है, but there is only one difference कि NI ने अपनी प्रोग्रामिंग लगा के अपना वो कर दिया, जिससे प्लग एंड प्ले कनेक्शन इजी हो जाता है ताकि आप परफॉर्म अच्छे से कर पाएँ. तो जब भी हम बीटेक स्टूडेंट्स यूजी स्टूडेंट के लिए बात करते हैं तो जनरली वी सजेस्ट USRP 2901. आफ्टरवर्ड्स अगर आपको लार्ज FPGA रिसर्च वगैरह पे काम करना है, लाइक USRP X310, इसको 2 ट्रांसमीटर 2 रिसीवर वाला बना सकते हैं, एंड देयर इज द N series.
N series is not coming, sir. Yeah.
It is 2 transmitter, but it is not that much powerful processor in this USRP. For that
So
USRP you have to connect that USRP with using Ethernet, and you need external power supply, और आप MIMO करना है, जो proper MIMO होता है, extension करना है, then USRP X310 series will be better.
Then will actually want to purchase that USRP?
No, that not. There is one more version, क्योंकि वैसे ही strong FPGA programming processor का है, N200.
N200, yes.
N210. यहाँ जो N210 है, N200 है, इसमें N210 में 1 ट्रांसमीटर 1 रिसीवर, इसमें एक स्ट्रॉन्ग FPGA होता है, साथ ही साथ इसको आप अपने रेफरेंस के हिसाब से जनरेट चालू कर सकते हैं. यहाँ पर N310 जो सीरीज है, इसमें 2 ट्रांसमीटर 2 रिसीवर आप सेटअप कर सकते हैं, ठीक है, X310 में. और ये N210 वाले अलग हो जाते हैं पूरा वो भी वो कई सारे लैंग्वेज में कनेक्ट कर सकते हैं. उसको आप मैटलैब से कर सकते हैं, उसको आप LabVIEW से कर सकते हैं, उसको आप जेन्यू रेडियो, बट रेस्ट 4 ये स्पेसिफिक आप जेन्यू रेडियो से ही जा सकते हैं, क्योंकि अभी जितने मरीन इंजीनियरिंग वगैरह पे जो यूज़ होता है, दे यूज दिस काइंड ऑफ थिंग्स, ठीक है.
all supports.
Open source. All supports open source.
This doesn't support.
It doesn't support that much open source, क्योंकि B210 है, पर प्रॉब्लम वही है कि हमारे पास ज़्यादा सपोर्ट अवेलेबल नहीं है, because we cannot rely on the open source ना that much. Keep it simple. They are just a BTech students, so
Okay. So in software defined radios from NI we have different variants of SDRs. So like the variants of SDR, like this SDR is so small that it is the size of a credit card, where we can carry this SDR in pockets. So we can use it on the field, like we can connect this SDR to the mobile phone as well. So it is like it's a very flexible SDR for carrying outside. So USRP B200 mini. It's a mini series. It's a miniature SDR. So then so these two are the same SDRs, so with enclosure and without an enclosure. So then we have the USRP B200, like which is the student lab SDR. So we can use SDRs in the student labs for gaining the understanding on the communication systems with and getting started with wireless communication. We can use the B200 or B210 series. So then if we want to have a standalone processing, so embedded series USRP. So in such a case we have the embedded series USRP as well. and we have the embedded series USRP in the rugged form also, that we can deploy it on the outdoor, which is this rugged series USRP, which can also be battery powered. And then we have the USRP for high baseband processing applications and all. Then we have USRP X series, so where we are the FPGA programming is open, and student, like everyone it's open for deploying the FPGA applications on the SDR. So then for doing any MIMO applications and all, like we have the USRP N series, so network series. And if we want to synchronize multiple USRPs together, such that like we can scale the MIMO system to like beyond 4x4 or up to till 128x128 or 256. So for synchronizing all of this USRP, we require some synchronizer. So that is provided by this octoclock device. So where we can synchronize multiple USRP for a MIMO communication system for establishing of a MIMO end-to-end system. For 5G and 6G, we will go for the USRP which is open for FPGA programming. So because like there the processing power is more, because like the difference is that like when we go for the USRP B200 and all, so the sample streaming rate is less, where we but when we for deploying the 5G stack or the 4G cellular stack, we require a high-end USRP which is capable of handling the sample more data rate, more data samples. So in such a case, we have to go for the USRP RIOs, or the reconfigurable IO, or the FPGA based USRPs. Okay. For the drone, like if we are doing the processing on the software, and in such a case we use the like a standalone FPGA, standalone USRP, USRP embedded series. So yeah, E series. It is so compact that like we can mount it on the drone and we can fly it. So the hardware will be of like half the size of this USRP, and it's also rugged. So it's also waterproof and dash proof. E series USRP. So and it also comes with multiple channels, like with 2 channel and 4 channel. So where we'll have four transmitter and 4 receiver at the max, and two transmitter and receiver. B2 mini we can do, but the difference is that like we interface the embedded series USRP with a gigabit Ethernet connection. So but we interface USRP B200 mini with the USB connection. USB, the maximum sample rate that it can stream is up to 61.44 mega samples. So on the gigabit Ethernet, like we get more processing power. Yeah, two-way communication it can do. Yes, in a loopback we can do. Loopback, yes. With a single USRP we can do a loopback, and if we have multiple USRP we can do end to end. USRP in so in general, like we can say universal software radio peripheral, like it's the software defined radio hardware which can be used for any kind of application when it comes to the RF. So like if we want to deploy any GPS application, like with the same hardware we can do GPS, like mobile communication, satellite communication, like all of the cellular communication application we can do. Suppose like if we want to do a Li-Fi, so communication over with the help of a visible light communication, we can also use USRP at which runs on the very low frequency, and we can use the RF to photon converter. So for doing the Li-Fi communication with the help of USRP also. So like as we can use USRP on the multiple communication applications, so we give it as universal software radio peripheral. It's a hardware that we can use it for different kind of applications. So if we see the architecture of USRP internally, like all of most of all of the USRP is having the same architecture. So like we have the host processor. So here the host processor will be the computer or a workstation where we will connect the USRP to the system. So on the host processor we can use the CPU. So which will be any Intel Core processor or AMD processor that where the software is run and that produces the samples, and or whether it can be a general purpose processor as well, where that can be a GPU, NVIDIA GPU as well. So this is on the like host processor will run the softwares, and we connect the USRP to the host computer with the help of interfaces. Like we have for bus series USRP, we have the USB interface. For embedded series USRP or the network series USRP, we have the Ethernet interface. For the X series or the high-end USRP, we have the like 10 gigabit Ethernet with the SFP ports. So in such way, we have a different interface for connecting. So we will connect the USRP to the computer or to the CPU to make it as a USRP based SDS system. So within the USRP, we have an FPGA which performs the baseband processing. So the FPGA will perform the baseband processing, which will generate the in-phase and the quadrature phase of the signals. So the in-phase and the quadrature phase signals are generated by the FPGA, and inside the FPGA we will have the IQ modulators, where the I and Q signal generated will be passed on to the IQ modulators inside the FPGA to generate the intermediate frequency. The intermediate frequency that is generated from the FPGA will be converted into the RF by mixing in the RF hardware. So in the RF hardware, we will have the digital to analog converter for converting the intermediate frequency of the digital signal to the RF to analog for transmitting, and at the receiver end we will have the analog to digital converter. So like depending on the desired waveform requirement, so suppose like we want to design any kind of waveform standard, so depending on the waveform requirement, the I and Q will be generated from the FPGA. So the waveform requirement can be like we can generate waveform by doing a source coding, so where we'll where we'll have the less number of bits for transmitting. So then we'll do the channel coding, so such that like we'll have the less number of error during the transmission. Then we'll have the interleaving functionality such that to protect the bits against the deep fades. So then we will have the bits to symbol mapping for transmission for converting the information bits to the I and Q samples. So then we will also do this upsampling in order to meet the Nyquist criteria. So then we will use the spectrum pulse shaping in order to like have the reduce have the efficient spectrum reuse. So like based on all of this frequency waveform generation requirement, the I and Q signals will be passed on to the RF hardware. So on the RF front end, the digital signal like digital intermediate frequency will be converted into analog with the help of digital to analog converter, and will be transmitted over the air with the help of a transmitter antenna. The signal that gets transmitted over the air with the help of transmitter antenna will also get scattered like in the over the air, will also might get reflected, and the signal that is transmitted over the air can be captured with the help of a receiver antenna. So the signal since it gets scattered and reflected, the signal will not be much powerful enough for processing at the receiver front end. So in such a case, like at the receiver end we have the low noise amplifier and the automatic gain control unit, so which will capture the like a noisy signal and pass it to a low noise amplifier such that we will get a constant signal, a roughly constant signal, which is good enough for processing at the baseband side. So this signal and automatic gain control unit will adjust the gain such that like we'll have the like proper like power of the signal for to be processing, and this signal is passed from the is converted into digital with help of analog to digital converter, and is again given back to the FPGA which is passed again to the IQ modulators, and the baseband processing is done on the FPGA, and whatever the baseband processing is done, the samples will be streamed back to the CPU with the help of an interface, and the samples will be captured by the software, either it be a LabVIEW or GNE Radio or any other software stack, and those data visualization can be done on the software also. And this is the generic architecture of all the USRPs. So when we say USRP based SDS system, so when we refer to the architecture, it's on the physically when we are connecting the USRP on the on the host processor side. So we will have we can use a CPU for running a software application or a GPU. So we can use a GPU for doing a software application where we can plot the spectrum like FFT and the waterfall plot we can plot. So like on the GPU, like we have a computer where we will connect the USRP. So we have connected the USRP with the help of Ethernet connection, RJ45 connection to the host processor. And this USRP is here we are having the baseband here we are having the baseband processor, and this is the RF front end, and this is the transmitter and the receiver antenna. So like the baseband the software will perform all the software processing on the host computer, and it will stream samples to the USRP with the help of interface, and baseband processor will take the samples and process the signal and convert, and the RF front ends what we have here will convert the baseband signal into the RF and transmit and receive over the antenna. So this is how we connect on the USRP based SDR system. So when we say on the software platform, we have the various flexibility of using the most popular softwares for doing the signal processing for communication application. Suppose if we want to use a USRP with a MATLAB, so we can run MATLAB. So we can also use if we want to deploy FPGA application, so we can write RTL codes with help of VHDL languages, Verilog and VHDL. So we can use Xilinx Vivado for programming FPGA directly. So then we can use LabVIEW, so for doing a graphical programming. So we can also program FPGA with LabVIEW also. So and if we want to deploy any kind of cellular communication in a fast way, so we have open source cellular stacks such as like SRS LTE or Open Air interface, which is the open source 5G or 4G stacks that we can directly run on the computer and connect the host USRP for establishing a 5G or the 4G base station. So then if we can also program the USRP directly with help of API and with the C++ program and Python programming. And so whatever the software that we run on the computer, host computer or a workstation, that software will communicate with the hardware with the help of a driver, which is called as UHD. UHD stands for USRP hardware driver. So and whether it being any kind of operating system, whether we are using the software on Macintosh, Mac OS, or Windows OS or Ubuntu Linux or any other Linux. So the way of communication is that USRP has to communicate with the software with the help of UHD driver only. So UHD driver acts as a bridge for establishing the connection between the host computer and the hardware platform. So in this way by running the software stack on the host and UHD for establishing the communication bridge, and hardware platform for reconfiguring the RF application, we can tell it as a full-fledged SDR based application, SDR based communication system. When we say, so in USRP we have different variants of USRP. So USRP was first developed by Matt ATAL. So initially GNE radio was an application that was founded by Eric Blossom. So during that days GNE radio signal processing was done with the help of data acquisition system. So and at that time there was a need for having a open source software where we can do signal processing on the software. In such a case GNE radio was developed. So during that days Matt ATAL also since the software, so signal processing on the software was open source, there was no open source SDR which supported this flexibility of using the signal processing on the software. So during this time ATAL research came forward and they developed USRP and made it open source such that we can use the flexible RF hardware for doing the signal processing on the software. And ATAL research developed a USRP in different variants. So it has developed a variants as a beginner USRP called as the USRP bus series, then standalone embedded USRP, and network series USRP, which can work as a standalone as well as network connected USRP, and high performance USRP, the USRP X series. So in this way ATAL research developed different kinds of USRPs. So when we say USRP bus series, so we have 3 variants in USRP bus series USRP. So these are the USRPs that SDR hardware that we can connect to the computer by using the USB 3.0 connection. So we have we have B200, B210, B200 mini, and within the B200 mini we have two variants, B200 mini I. So like the difference here is that like USRP, all of this USRP supports a frequency range from up to 6 gigahertz, from 10 megahertz to 6 gigahertz. And so USRP B200 comes equipped with a single channel. So like we are here in this USRP B200, we will be having only one channel, so one transmitter and one receiver. So when it comes to USRP B210, we will be having a 2 channel. So like we will be having a 2 transmitter and 2 receiver for doing a 2x2 MIMO system. So then when we on the B200 mini, we will be having only one channel. And in this B200 and B210, we will also have this these 3 additional ports what we can use for synchronizing multiple USRP. So these ports are called as like clock and reference port. So like we can have multiple USRP, give a common clock to both the hardware, and make it a MIMO system by synchronizing multiple hardwares. So all of this USRP comes equipped with the Xilinx Spartan FPGA, and the RF front end is from the analog devices RFIC. And so the maximum bandwidth that we can tune from this USRP is 56 megahertz, and the frequency is up to 6 gigahertz. And this USRP like find application is the beginner USRP, like which find applications like for doing a frequency modulation, like any kind of digital analog modulations, and rolling out like testing out the 4G or 5G signals. So like all of the applications can be like a beginning application can be done with the help of USRP bus series. So and the specification of the bus series USRP is as listed here. So like we will get the maximum up to 2 channels in this bus series USRP with minimum 1 channel. And so the maximum bandwidth that we can operate is of 56 megahertz. So if we want, if on the B210, if we go for MIMO system like 2x2 when we do, so the bandwidth also comes down. So we'll get we'll operate at the maximum of 30 megahertz of bandwidth when we do a 2x2 on the USRP B210. Since like we are interfacing with the help of USB connection over there, and the data port is integrated onto the PCB, like on it's connected. And the maximum sampling rate or the throughput, the samples what we can stream from the host to the like USRP, the FPGA is 61.44 megasamples per second. So this is the maximum data rate that we can achieve in the USRP bus series USRP. So then we have embedded series USRP. Suppose like if we want to have operate USRP on a standalone mode where we don't require the host for programming. So in such a case, we can use embedded series USRP, where this hardware comes with a Xilinx Zinc processor. So where it will have a inbuilt ARM core processor that runs a Linux within the US hardware. So we can use the USRP directly on the Linux, and we can control the FPGA and the processing controlling like transmission and reception of the signal directly from the Linux that is present inside the hardware. So and in the embedded series USRP we have 3 variants: USRP E310, E313 and E320. So all of the embedded series USRP comes with a 2 channel. So we will have 2 transmitter and 2 receiver, and these USRPs we can interface or we can connect it to the host computer or the workstation by using the gigabit Ethernet connection. 1 gigabit Ethernet connection is required for this connection, and so the maximum the maximum bandwidth that we can achieve with this USRP is also again 56 megahertz. So and it comes with like RTX 7 FPGA and the Kintex 7 FPGA on the high-end USRP. So on the like USRP E310, E320 and E313 we have the lesser FPGA, and on the E320 we have the larger FPGA, which is also open for FPGA programming. So we can also deploy FPGA based applications on the hardware, so and by writing the RTL codes. So then we have the analog front end. It's a integrated USRP where the RF front end is integrated to the along with the baseband processor, and the analog front end is from the analog devices. And so the maximum the throughput that we can or the data samples that we can stream is of 61.44 megasamples. So we can interface with the help of a normal Ethernet cable or a gigabit Ethernet cable up to 10 gigabit with the help of SFP terminations. So then after embedded series USRP, we also have network series USRP. So in network series USRP, this is the USRP what we can use as a standalone hardware as well as the network connected hardware. So we can this network series USRP, like we can deploy this USRP in, on any remote location, and we can control this hardware over a network for any kind of applications. So and this hardware is mostly preferred in for doing the MIMO applications. So in the network series USRP, we have 5 variants, which is USRP N200 or N210. In the N200 and N210 N2 series, we have 2 variants, N200 and N210, and we have N300, N310, N320 and N321. So the difference here is that USRP N210 is the basic network series USRP. So this USRP comes with a single channel. So we will have only one transmitter and one receiver, and we can interface this USRP to the host computer with the help of gigabit Ethernet, 1 gigabit Ethernet connection only. And if we want to extend this USRP into a MIMO system, so this USRP comes with a MIMO port. So this port is the MIMO extension port. So where we will get a MIMO cable, and we can cascade multiple of this USRP with the help of MIMO cable for establishing the MIMO system. So here the synchronization is done with the help of MIMO cable only, but on the other USRP, we can do MIMO by synchronizing the USRP with the help of LVO sharing. So each and every USRP here will get LVO inputs, and USRP N321 will get the LVO output. So we can make use of USRP N321 as a master USRP, like the high USRP, and we can output the signal like synchronization, like local oscillator sharing signal from the USRP N321 and feed it to USRP N320. So such that like we can synchronize this to USRP. So USRP N321 comes with 2 channels, maximum of 2 channels, like where we will have only 2 transmitter and 2 receiver. And if we want to make it as a 4th channel, like suppose we want to do a 4 cross 4 communication, in such a way, in such case, like we can output the local oscillator clock from this USRP, feed it to this USRP N320, which is again a 2 channel, such that like we combine both the USRP to make it a 4 channel USRP. And we can extend this channel counts by cascading multiple N321, such that like we can achieve up to beyond even 256 cross 256 as well. So and if we want to do on a single hardware, if we want to have like 4 channels, so then we have USRP N320 N310, so where we have the 4 channels over here, and we can combine USRP N320 with N321 as well with LVO sharing, such that to make it as 4 channel and 2 channel, like 6 channels USRP, 6 channel count USRP. In this way, like we can expand the MIMO, we can scale up the MIMO by having the network series USRP, and this USRP is built as a like a high performance USRP, where this USRP where the FPGA is open for programming in here. So we can directly program FPGA, and this USRP is supported only for open source software. So open source software such as like GNE Radio or open source C++ programming and Python programming, and UHD with help of UHD API, we can directly communicate, directly program with these 4 USRP. And this USRP is supported both for LabVIEW and as well as open source. So here the support is only for is both for open source and LabVIEW, but for USRP N300, N310, N320 and N321, the support is only for open source. And all of this USRP also comes equipped with a GPIO connection. Suppose like if we want to do any kind of IoT application, like we want to do health monitoring. So when we deploy this USRP on the remote location, and we want to monitor the system health, so in such a case, like we can use this GPIO ports that are present in order to like give out the signals, like digital signals from the hardware, and we can process the digital signal on the like with the help of the other embedded processors we can do it.
Which USRP is promoted by
We are giving both NI and ATAS USRP. ATAS research is a part of NI only.
But some say
Mm.
USRP have a support of open source,
Yes.
and due to this open source, you don't purchase LabVIEW software.
No.
So why you promote that USRP? Because
Sir,
Which?
I am giving the answer because that is a NI user, and we are bonded with NI. Company is NI, they developing NI, okay, and they didn't say us ki don't sell ETAS user. Based on the customer requirement, we understand. If you want to run a UZ lab, so you have a specific setup. So there will promote you the NI USRP only because easy connections, USB based connection. If you really want to do the project and work and research, then we come and we suggest you, sir, don't go with the NI. You will get various limitations, and later you will scold us कि आपने हमें NI USRP दे दिया. Then come with the ETAS. Okay, ETAS USRP are less. Okay, ETAS USRP are more expensive than NI. Okay, and for the ETAS you have to understand various configurations. Sometime ETAS का सामान मैं आपको बेच देता हूँ, लेटर यू कैन टू नो कि ओके मुझे एक्स्ट्रा कुछ और भी कनेक्टर्स मुझे परचेस करना होगा. वो भी चलता है कस्टमर्स को, क्योंकि वो लेटर और परचेस कर लेते हैं क्योंकि उनको ओपन सोर्स का मिल रहा है. वी प्रमोटेड NI USRP जस्ट बिकॉज ऑफ द हम कस्टमर की नीड्स रिक्वायरमेंट को समझ के हम उनको बताते हैं. इवन अगर मैं विविडियन नहीं होता, NI होता, तो वहाँ पर हमारे किसी भी उसमें हम अलाउ नहीं होते कि नॉन NI USRP के बारे में बात करें. हम नॉन NI USRP के बारे में, बट ये विविडियन है एंड द मूर्ति joined विविडियन as a and he work on only JNU radio. NI अपने वहाँ पर केवल because they also want their own that क्या होता है इसको ecosystem. They want their own ecosystem की easily connectivity provide हो. As I said, at evening 4 a.m. Sorry, 4 p.m. and night 10 p.m. you will call me. Yes, I am stuck somewhere and my USRP is not working. So if you are using an USRP, so I can help you from anywhere of this India. But if you say I am working on a that's MATLAB, so we are not expertise on the MATLAB. So we based on the for the customer support, for based on customer support, उसमें भी हम ये प्रेफर करते हैं कि हम जिसमें कस्टमर को सपोर्ट कर पाएँ. लेटर ऐसा ना हो कि मैंने आपको सेल कर दिया और मैंने एक बार डेमो कर दिया, डेमो के बाद आप ढूंढ रहे हैं सपोर्ट एंड सॉल्यूशन एंड यू आर नॉट एबल टू गेट द प्रॉपर सॉल्यूशन. तो ठीक है, वहाँ पर ब्रॉड स्पेसिफिक होने के बाद NI यू मैं नहीं भी रहूँगा, सो दे विल फ्यू पीपल विल कम इन द NI एंड दे विल लर्न LabVIEW एंड दे विल गेट ऑल दिस रिसोर्सेज, क्योंकि NI ने अपने एग्जांपल वगैरह डेवलप करके कोड वगैरह करके दिया है. Same we don't know from where we will get about the LabVIEW and MATLAB or Python based code. And if you'll get that code, so also I am not that much sure कि वो रन करेगा चलेगा नहीं करेगा, because मुझे कोई हवा ही नहीं लगता जब मैं टेक्स्ट बेस्ड प्रोग्रामिंग लैंग्वेज में आता हूँ, क्योंकि हमारी पूरी की पूरी 10 साल की मेरी जो जर्नी है विद NI, दे हैड ट्रेन माय ब्रेन फॉर दैट स्पेसिफिक. अगर आप कल के दिन यहाँ पर कोई 5G रिसर्च लैब यू विल कम and if you say if you will come to me and if you say, sir, I want to develop a 5G 6G research lab and beyond the 5G 6G research lab vehicle radar test setup I want to do, या मैं satellite communication setup के लिए मैं testing कर रहा हूँ, then we propose you the ETA species without any question. Directly we come and we propose. Have you this way that export done series?
No, it's in the coming series.
Like export. This is export done. It's can run with the JNU radio LabVIEW, and this is export 40 after this. So export 10 जो है उसमें 4 ट्रांसमीटर है, 4 रिसीवर है, एक ही हार्डवेयर and 400 मेगाहर्ट्ज की बैंडविड्थ है. And export 10 you will get 8 ट्रांसमीटर 8 रिसीवर. तो आपको दोनों दो ऐसे हार्डवेयर लेने से आपकी 8 ट्रांसमीटर मैमो बन जा रहे हैं. आपको बहुत सारे बड़े सेटअप नहीं लेना है. तो उस समय हम आपको ये वाला सजेस्ट करेंगे इस टाइप की USRP. तो कस्टमर के रिक्वायरमेंट्स के हिसाब से हम करते हैं. बिकॉज अगर ये IIT BHU होता और ये प्रोग्राम चल रहा होता तो हम स्टार्ट ही करते विद ETAS USRP. मैं आपको बार बार इस पे JNU रेडियो पे नहीं, क्योंकि मैंने सर को जो कल आए थे अतुल सर, सोनम मैम, इन सभी को जो हमने सेल किया है सब ETAS बेस्ड USRP ही सेल किया, क्योंकि उनकी PhD So they collect only 10% knowledge, उसके बाद सीधा जंप करना चाहते हैं भाई इतना दिमाग कौन लगाए, क्योंकि क्वेश्चन बैंक पढ़ के पास हो सकते हैं, अगर हम किसी को 500,000 रुपए दे के भी हमारा काम बन सकता है तो हम प्रोजेक्ट भी कर लेंगे, तो वो आते हैं they came to us and they said कि हमें
बहुत opportunistic होते हैं ना।
होना पड़ता है ना सर, हर 6 महीने में हम सब्जेक्ट चेंज कर देते हैं बेचारों का, अरे सब्जेक्ट में घुसे तो रहते हैं बेचारे, पुस्तक खोल के पुस्तक को देखे रहते हैं, सब्जेक्ट चेंज हो जाता है। बस M1 जो मैथमेटिक्स सब्जेक्ट है, ग्रेवाल की बुक वही उनको 2 साल काम देता है और बैक लग गया तो 3 साल। सर आफ्टर दैट दे केम टू अस, उनका जो स्टूडेंट था उसका नाम जिनसो, ही केम टू मी एंड ही सेड कि सर मुझे इसमें सपोर्ट चाहिए, तो मैं हमारा सुमित आईआईटी जोधपुर से, उसने आरएफ में ही किया है, सो संदीप सर के अंदर, मैंने उसके साथ लगा दिया। आफ्टर 2 to 3 days 4 days उसने कंटिन्यूसली मेल करना चालू किया जिनसो ने, मैंने बोला सुमित इसको तो करो, मैंने एक स्पेसिफिकली गाइडलाइंस वाला निकाल दिया, ठीक है उसके लिए। ही स्पेंड नियर अबाउट 30 days, देन ही केम टू मी, सर वो बीटेक स्टूडेंट है और उसे वीडियो स्ट्रीमिंग करना है वायरलेसली फ्रॉम वन लोकेशन टू अनदर लोकेशन, और उसको ऑनलाइन सपोर्ट यहाँ से बैठ के चाहिए, जबकि उसको खुद का उस तरफ से कम्युनिकेशन की प्रोग्रामिंग नहीं आती, तो मैं पूरा प्रोजेक्ट डेवलप करके नहीं दे सकता, वी आर टेक्निकल सपोर्ट, प्रॉब्लम वहाँ पर फिर फंस जाता है। तो इसीलिए एनआई का कॉन्सेप्ट है कि अगर हम बीटेक वगैरह पे जा रहे हैं तो एनआई बेस यूएसआरपी टीच करते हैं, जिससे हम LabVIEW भी ट्रेनिंग दे सकते हैं, वो LabVIEW तो हमारे पास ट्रेनिंग मॉड्यूल शेड्यूल सब कुछ बना कर रखा हुआ है, तो हम उसमें दे सकते हैं ताकि स्टूडेंट खुद से लर्न करें और लर्न कर सकते हैं, तो क्योंकि मोस्ट ऑफ द 99% पीएचडी स्कॉलर्स खुद से सब कुछ लर्न कर लेते हैं, उनको बस बेसिक बता दो, क्योंकि उनका काम ही होता है 4 साल उसी चीज़ को ग्रो करना, पर बीटेक वालों के पास एक स्पेसिफिक 25 डेज होता है, उसमें भी बहुत सारी चीज़ें उनकी चल रहे होते हैं, तो वहाँ पर इसीलिए हम यूएसआरपी एनआई पिच करते हैं स्पेसिफिकली, क्योंकि हम सपोर्ट दे पाएंगे, बेस सपोर्ट, कि बेस यदि और भूल गए तो फिर तो सर बहुत सारी चीज़ है। सेल्स करते करते इतना बोलने का आदत हो गई।
So, so this is the specification on the network series USRP. So we have different frequency ranges, which is up to 6 GHz only. But the beginning of the frequency range is different depending on the USRP N200 series, N300, and N320 series. So like on the N320, we have the frequency starting from 3 megahertz to 6 gigahertz, but the bandwidth is high. So we have a bandwidth up to 200 megahertz on the N320 series. So suppose it can be N320 or N321. But when we come to the USRP N300 or N310, so we have the reduced bandwidth. So where the maximum bandwidth that we can achieve on this hardware is only up to 100 megahertz, with the frequency range being from 10 megahertz to 6 gigahertz. So and on the USRP N320 and N321, we get the high-end ARM Cortex like Xilinx Zinc SoC, but on the USRP N300 we get only the Spartan FPGA. So like since it's only on the Spartan FPGA, this FPGA is not open for programming, but on the Zinc SoC we can operate as a standalone hardware as well. So with ARM Cortex processor, and the FPGA, which is the RTX and the Kintex FPGA, are open for FPGA deployment, application deployment as well. So when it comes to the MIMO system, like USRP N320, N200 and N210 comes with only one channel. So but on the N300 and N310 we have two variants with 2 channel and 4 channel variant, and we have on the N320 we have only 2 channels for scale, but we have the LVO sharing for scaling up the MIMO system. So how we will connect this hardware to the host computer with the help of gigabit Ethernet connection, 1 gigabit Ethernet connection, or a 10 gigabit Ethernet connection with SFP termination, small form factor termination. Then we can also use the QSFP connection on the high-end network series USRP, quad SFP.
Sir, you said now there is one more difference. If you will go with the latest USRP, then you need extra. If you will come with the NI USRP, so for the higher, you need just a Ethernet connection, and if your computer is capable, okay, and that's Ethernet connection is available, so आप अपने NI की किसी भी USRP को अपने लैपटॉप पे कनेक्ट कर सकते हैं. और अगर Ethernet अगर उसमें जाते हैं, then you need to purchase a PCI card and you have to install on the PC. That will increase your that's signal
Data data streaming rate.
speed to the 1 gigahertz or 10 gigahertz. वो एक challenge होता है वहाँ पे.
So and in all this higher series USRP we get two SFP terminations, so that we can use one lane for transmit like sending the data samples from the host to the FPGA, and other stream for receiving the data samples from the FPGA to the host stream. So like two-way communication is possible on the high-end USRPs, high-end network series USRP. So for as like high precision application requirement. So and the analog front end on all of this USRP is provided by the analog devices RFIC. So RFIC 2961 and AD9371. So then if for doing a very high application, like high processing application, we have a USRP X series USRP which is developed for the next generation wireless communication. So here this USRP is a modular USRP where we get the baseband processor separately and the RF front end separately. So depending on the application requirement, we can choose the RF front ends. So suppose like we have a frequency requirement on the L band, like very on the low frequency, so we can choose a RF front end for that particular frequency range itself. So suppose if we want to have a frequency range like a very high bandwidth, like suppose we want to operate on 160 megahertz bandwidth, so we can choose the data boards depending on the bandwidth requirement. Suppose if we want to have only 40 megahertz of bandwidth, our bandwidth is so limited, application requirement bandwidth is limited, so then we can choose the respective data board. In such a case, like we have USRP X series, which is a modular hardware that comes with a high-end FPGA, which is the Kintex 7 FPGA. Here the baseband processor is a Kintex 7 FPGA that is open for programming, and this USRP comes with 2 channels. So we have 2 transmitter and 2 receiver over here, and we have the GPIO connection for the putting out the hardware L signals on the digital output. So then we can synchronize multiple USRPs, multiple X series USRP with the help of by giving the common clock and the common PPA signal to the hardware, and we can also synchronize this USRP with the help of a GPS DO. So like this USRP we have this slot where we can insert a GPS disciplined crystal oscillator here, such that like when we connect this USRP to the when the USRP gets synchronized to the real GPS signal, so the GPS driver will start producing 10 megahertz constant clock to the hardware. So such that like we can use GPS DO, and we can have multiple SDR on the different terrain, like different locations, get synchronized to the GPS signal for synchronizing the USRP at a long distance. With the help of GPS signal, we can synchronize this hardware, and we can also, and these are the data board slots where we can insert 2 data boards. So like this data board slots is also like flexible. On the one slot we can insert a like a low frequency data board, like up to, suppose for example like data board up to 2 gigahertz we can insert here, and we on the other slot, like if we want to have an application up to 6 gigahertz frequency range, we can insert a data board, like a different data board here. So different combination of data boards can also be used on the hardware, and this is the FPGA programming is hardware Kintex FPGA is present within this heatsink, which is the Kintex FPGA, and we have this dual SFP terminations which we can use on the 1 gigabit and the 10 gigabit lane. We can also make these 2 lanes work at 10 gigabit, and use one lane for streaming the sample into the hardware and one lane for streaming the sample outside the hardware. So for like high precision application, we can use this SDR for prototyping the real time applications and field deploying, deploying real time applications. So the specifications is that like the frequency range starts from the DC to 6 gigahertz, the hardware supports. Then we have 2 variants, USRP N300 and X300 and X310, which both are having the Kintex FPGA, but X310 will have the larger FPGA compared to the X300, with the part numbers of the FPGA being different. And so we have 2 channels, and the maximum bandwidth that is supported by the X series USRP is 160 megahertz of bandwidth. So we can interface this USRP with the help of 1 gigabit, 10 gigabit as well as PCI connection. So like for the workstations and all, like we have the PCI slot, like PCI to MXI connection. So we can use this PCI to MXI connection for interfacing the hardware to the host computer. Yeah. This still how much? Slides, 15, 20. Yeah. Okay. Yeah. Okay. So this. So like when we say the USRP, like we have two variants, which is the NI variant of USRP and ATAS variant of USRP. Both the USRPs is by National Instruments only, but NI ATAS model is the USRP that supports the open source software out of the box. But NI USRP models are the USRP hardware that supports LabVIEW out of the box. So we can comparison between the hardware specification of both the hardware is almost exactly the same. Suppose like if we consider USRP X310, where we want to have a receive only operation, such that like we can operate only on up to 6 gigahertz. So we can use USRP X310, and since it is modular, we can use the data board called as TwinRx. So this TwinRx is a data board which is only receive only data board, and we will have 4 channel reception over there in the hardware. So and if we want to synchronize the USRP with the help of a GPS DIVO and GPS signals, we can also have GPS DIVO. So in this way we can modular, like depending on the application requirement, we can customize the USRP X310. But on the NI platform, we have the same USRP. The hardware specification is the same, which is USRP 2955. So the hardware is same, the nomenclature is different. So the difference here is the difference comes within the with the firmware that is present inside the FPGA. The firmware that is present inside the FPGA of USRP X310 is different, and the firmware that is present inside the USRP 2955 is different. So the firmware that is present within 2955 will support only LabVIEW. So the firmware which is present within the USRP X310 will support the open source software. So in the different lies on the firmware level present inside the hardware. So as this example, like we have different variant also. But when we come to the network series USRP, high network like USRP N310, N320 and N321, so we do not have a NI model, because like these USRPs are built depending on the application requirement. So like specifically for MIMO requirement. So and here the FPGA is open, and we can also program with C++, Python, and all of this. So for this application, the NI variant is not there. But in order to overcome this drawbacks, we have the USRP X410, which will support both LabVIEW and GNE radio, like with a single hardware. So with the same specification. So then on the standalone basis also, we have USRP E320 and E321, and the NI variant is not there, as they are the embedded series USRP, because they run embedded Linux within the hardware within the USRP. And the bus series or the mini series USRP is there, and we can see here the software support we can do. So for this NI USRP and all, we have this, we can program the FPGA, we can do the host programming by using LabVIEW, and we can also do the host FPGA programming by using the LabVIEW FPGA. So where the FPGA can also be programmed by graphical interface. Then on the GNE radio side also, we can make use of the USRP X310 and the X320, and FPGA programming can be done by developing RTL codes by using the framework called as RF network on chip. So here we will be writing the we will be using the Xilinx Vivado and writing Verilog codes. So the difference between the ATAS and NI USRP is that all the ATAS USRP comes as a modular device. So we get the daughter board and the motherboard separate, but when it comes to the NI USRP, it comes as a like a fully assembled USRP. And the software support that that comes from the ATAS USRP is that like it supports Python, MATLAB, and C++, GNE radio out of the box. But and we can also use USD API for programming, for the directly programming the USRP. But on the NI USRP, like out of the box, the NI hardware is supported only for LabVIEW and MATLAB. So, and if we want to communicate with the, like say, do a programming on the JNE radio and Python, it is not possible with the help of NI hardware. It is possible only with the ATAS hardware. So, and when it comes to the customer support, so we have a good customer support on the NI platform, because but on the ATAS USRP, when we go, since the hardware is open source, so the community, we have to, for any kind of support that is related to the ATAS USRP, we have to approach the open source communities. So for getting the queries, so like we have to use the open source like community, like GitHub, GitLab, so like where we can address our queries. So but on the NI side, like we have like anytime 24 hours customer support available for the NI hardwares. So like we can use this NI SDR platform for researching on the 5G or beyond 5G. So like for researching on the, for giving the advantage of doing the quick research on the academic level, we have the bundles are developed by National Instruments. So like which is there are bundles like research bundles developed for depending on the application requirement. Like some research institute want to do a research on the open source platform, some research institute want to do a research on the LabVIEW platform. So depending on the, and some research institute want to do a research on the multi-millimeter wave. Depending on the requirement, we have the different bundles. So we have a bundle called NI OI reference architecture. So where we will do the 5G research on the open source platform. So where here we can use the USRP X410. So the high-end USRP which is configurable, where we can deploy the open air interface is a 5G stack which is open source on the GitHub, and this stack can run on the computer, like host computer for generating for acting as a base station. And so the core network runs on the computer, and the GNB and the user equipment, all the software stack is available from the open air interface. So the hardware, the radio front end for this software stack is the USRP what we can use. So we can club multiple USRP to act as a base station on the MIMO system, or we can use the same USRP to act as a user equipment also, for in order to establish an end-to-end communication system. So and the server runs all the software stack. So and when it comes to the OS setup, we have this setup like this. So here we will have a server, a very high performance workstation or a server which will run the core network, and this core network will run the software stack, and all the configuration is provided on the Docker images, and we have the GNB, which again runs on the server. The software stack runs on the software, but USD is also USRP gets connected to the server with the help of USD, and USD bridges the communication gap between the host processor and the FPGA, and the USRP acts as a RF front end for having the base station. So on the user equipment side, so we can have our mobile phone such that like we can test out the COTS UV. Then we can have the laptop as a user equipment, so we can connect to the network by using the this Quactel modules. This Quactel is a third-party user equipment module which acts as like a SIM card for connecting to the network. So then we have the then we can also use USRP as well for connecting to the base station. So this is the base station, and this is the user equipment. We can use mobile phone or a laptop or a USRP directly for having the end-to-end communication system. So in this way, like this is the OI reference architecture, or the bundle that is provided by National Instruments, and depending on the research requirement, we have different bundles, like a bundle with USRP X310 or X410, or USRP N310. Like suppose for both X410 and X310 operates on 4 channel. So like X410 is also yeah. Okay. This one. Okay. So how we can use USRP in the academic levels? So like we can use USRP for learning on the 5G and beyond on 3 levels, like for bachelor students or for the postgraduate level students, as well as the like research scholars. So we can use the USRP on the bachelor students, like for students to gain understanding on the mobile communication, for doing any kind of application such as like learning the basics of 5G, like how the 5G network can be established, how we can connect to a network, and how we can run the software stack. So all of this basic understanding can be gained on the UG level by using the basic hardware such as like the USRP, B series USRP. We can use this USRP to deploy the base station, and we can have the basic understanding such as like the basic additional modulations that we can do, such as the QAM, OFDM. All of these modulations are related to the 5G communications, NOMA and all we can do with the help of the USRP, B series USRP. We can this on the student level. Example, like what is the speed test that we can do. So when we are connecting on the mobile phone, when we are using USRP as a base station, using mobile phone as a UE, so what is the data rate that we are achieving on the established network. So these kind of experimentations can be done on the bachelor students lab, but again we have on the postgraduate student lab. Suppose like if we want to students want to analyze the like throughput, like any kind of beamforming application or MIMO application, MIMO deployment, and security analysis, network security, and all of these application scales applications can be deployed on the postgraduate level lab. And students on the postgraduate level lab, we can make use of the high-end USRP which are open for FPGA, and we can like where the students also gain access for doing the FPGA programming, for doing the baseband processing of the 5G or the 4G stacks. So all the physical layer functionalities is also open for programming on the postgraduate labs. So then when we go for research scholars or the like academic research oriented lab, so we can use for USRP, we can use the USRP SDS for doing a millimeter wave research. So we can use USRP for protocol analysis like 5G or 4G, any protocol analysis. So any IoT connectivity, so like USRP related connectivity and all. So those things we can establish. We can develop a full-fledged test bed, so for test analysis and measurement. So MIMO experimentation, all of this can be done on the research oriented on the academic research level labs. So on the academic supports, like how we support for the academic research is that like we provide USRP, like the for the student lab we provide the basic USRP hardware such as like the USRP where they can deploy the basic experimentations. And if students want to work on the open source, like we have the open source bundles. So then if if students wants to do the research on the LabVIEW platform, so then we have the USRP that can be connected to the LabVIEW PXA chassis as well, and work with the LabVIEW for doing the research. We have the LabVIEW bundles. So then we have millimeter wave bundles as well, and for doing the MIMO connection we also have the MIMO along with the MIMO millimeter wave communication as well. So in this way, like we have the different bundles that is available for supporting the academic research for doing the 5G research activities. So one such case of 5G establishment is that like we have a company called as Spirent Communication, which has established a end-to-end 5G network with the help of with the help of NI USRP hardware and a PXA chassis. So here they are using the PXA chassis that runs the core network within the controller that is present within the PXI, and for the RF front end we are having a multiple USRP for the MIMO application. That establishes that acts as a fully standalone G0B base station. So then we have on the user equipment we are having again the same PXI chassis like a PXI card with a controller that runs the user software stack, and the base station like a user equipment RF front end is provided by the USRP. And in this way, end-to-end communication standard is 5G is established by Spirent Communication, which is commercialized on the with help of NI USRPs, NI hardwares. And Another example of application example of USRP hardware is that like a company called as Skysafe has used USRPs for drone detection and mitigation application. So they are using for the military application where they can detect the drone over like in order to protect the like very important areas like key areas like military application, airports and government places and all. So they have used USRP as a radar for detecting the drone that is entering into the border region, and using the GPS like mitigation strategies, just safely landing the drone onto the safe location in order to eliminate the drone threats. So in this application, like the same hardware can be used on the different application also. So in this way, like this is the like a field deployed drone defense application that what they have developed with the help of NI hardware. So it's mobile on the they have integrated this hardware onto the track itself, and so for scanning the sky for eliminating any drone threats. So and not only on the our communication side, like we can also use the USRP, like the high-end USRP for deploying any kind of latest technological trend like artificial intelligence for signal processing. So like we have done the deep like a company called DeepSeek is using the deep learning algorithm, has developed the deep learning algorithms for monitoring the spectrum and classifying the signals. So they have done the baseband processing on the NI USRP N series. USRP N310 for monitoring the spectrum with help of like a deep learning application. So yeah, that's yeah. Thanks. Thank you.
क्वेश्चन है ये सर वगैरह के कि हाँ क्यों 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 वायरलेस कम्युनिकेशन या बार बार सोच रहे होंगे कि बीटा कहाँ से आ गया है, नहीं क्या कर रहा है अभी, राइट? बीटा से कंपनी था जिसने यूएसआरपी बनाया, एनआई ने उसे खरीद लिया, बात इतना ही है। जैसे अभी इमर्सन कंपनी ने एनआई को परचेस कर लिया। यहाँ पर परचेसिंग कई प्रकार की चीज़ें होती हैं। आप लोगों ने एक बहुत दुनिया में सबसे ज़्यादा और अच्छा मोबाइल बनाने वाली कंपनी कौन थी सबसे पहले, जिसके पास सबसे ज़्यादा पेटेंट रहा?
मोटरोला।
सबसे पहले फ्लैगशिप उसने निकाला, सबसे पहले कीबोर्ड के अच्छे अच्छे फीचर्स निकाले, गेमिंग उसने डेवलप किया, उसकी प्रोसेसर सबसे बेस्ट थी। कहाँ गया? एप्पल कंपनी ने इसे परचेस किया। एप्पल ने गूगल ने उसको बोला कि भाई तुम हमारी अपनी टेक्नोलॉजी शेयर करो, और बोले कि भैया जी हम शेयर नहीं करेंगे। वो आया पैसा लेके, मोटरोला कंपनी को खरीदा, उसके सारे पेटेंट अपने नाम में किए, फिर उठा के बेच दिया बाहर। रियल मार्केट यही चलता है। आपकी कंपनी है, मुझे आप पसंद आए, आप मेरे लिए काम नहीं करोगे, मैं आपकी पूरी कंपनी खरीद लूंगा और आपके साथ आप फिर मेरे लिए काम करो। इसे बोले एक्वायरिंग। आपको एक्वायर किया, लेकिन उसमें आप सर फोन कर दिए वहाँ पे